Hi, Assalamualaikum. Chapter 5, Hydrocarbon. Let's continue with lesson 63, Synthesis of Alkene. Today, we are going to draw the structures of alkenes and how to prepare them from dehydration of alcohols and dehydrohalogenation of alkyl halides. Then, we have to explain that the major alkene produced is of according to the Zaitsev rule. This is the flow chart of what we're going to do in lesson 63. Introduction and IUPAC name we have done. A little bit of physical properties also we have done. And then we are going to do elimination reaction, two of them, hydration of alcohol and dehydrohalogenation of haloalkene, in order to synthesis alkene. Electrophilic addition is lesson 64 and oxidation is lesson 65. Alkenes are divided into aliphatic and cyclic. The aliphatic alkenes has general formula CnH2n isomeric to cycloalkane. Because of the restricted rotation of carbon-carbon double bond, cis-trans isomerism will occur. And cycloalkenes has the general formula CnH2n-2, which is isomeric to alkyne. Let's do example 5.1 together. Draw the isomer of C3H6. Here we can see that aliphatic alkenes are also isomeric to cycloalkane. So what we have to do is draw propene and the functional group isomer, which is cyclopropane. What about C4H8? It has cis-trans isomerism. So the cis-2-butene would have a methyl group on the same side, whereas trans-2-butene would have the methyl group on the opposite side. It would have a different physical properties and also boiling point, since the polarity is different. Next, we want to draw all the isomers of C5H8. These cycloalkenes, a cyclopentene, is isomeric to alkynes. So the functional group isomerism for a cycloalkene is an alkyne. Therefore, we draw cyclopentene together with pentyne. Now, let's look at how are we going to prepare alkenes. The first process is dehydration of alcohols. The second one is dehydrohalogenation of haloalkene. Both reaction is an elimination reaction. This is the mind map that you have to write in your course book at page 215. On the top left, after you've written what is Zaitsev rule. On the first box, you will draw the general formula of alcohol. The reagent is given, so you don't need to write this down. On the second box, you will write the general formula of a haloalkene. Potassium hydroxide, alcohol reflux is already there in the mind map. I've mentioned Zaitsev rule just now. What is it? In order to determine the major product of elimination reaction for alkene, we need to use Zaitsev rule. It states that the major product would be the most stable alkene, which is the alkene that has a greater number of alkyl groups R. Here we know that elimination reaction would usually gives major and minor product because we are going to produce the double bond either on the left side or on the right side. So we need to find the most stable alkene where it is the most highly substituted alkene. Let's do example 5.13, dehydration of alcohol, question number 1. I am drawing the structure of ethanol over here where hydroxy group is attached to this carbon number 1. And we are going to produce double bond over here. Therefore, we are going to eliminate OH and H so that water is going to be produced. So I'm going to rub this off. So now we have produced an ethene. Next, let's do question number 2. I am expanding the carbon so that we can see all the atoms and all the single bonds. Okay, this is the OH over here at carbon number 2. This is a 2-butanol. So what we're going to do here is we want to eliminate OH. Yes, but which hydrogen does it want to take with it? Is it the hydrogen on the right side or the hydrogen on the left side? So if we take the hydrogen from the left side, we're going to produce the double bond between carbon number 1 and carbon number 2. It means that this alkene is going to have only one alkyl group, R1. But if we take this hydrogen, we are going to produce double bond between carbon number 2 and carbon number 3. So what happened is we are going to produce one alkyl group here and also one alkyl group here. So for this second structure, we are going to have 1 and 2 R. This is R1, this is R2. So which one is going to become the major product? Yes, the second one is the major product, whereas the first one is the minor product. So we are actually following the Sachs-Zeff rule because Sachs-Zeff rule states that the major product of the elimination process would be the alkene that has the most number of alkyl groups. Right, question number 3. Let's draw the cyclopentanol. Okay, as we are going to remove the hydroxy group here, if we take the hydrogen from here, it's going to become the same as we take the hydrogen from there, because if it's here, the double bond is going to be the same as if it's on the right or left of it. So we are going to produce a cyclohexene anyhow. Let's do question number 4. This is a cyclohexanol. you have an OH here, and I'm expanding the structure. There is one hydrogen here, and there is 1 and 2 hydrogens over here. OH is going to be eliminated together with either this hydrogen on top or this one. So if it takes the hydrogen on top there, it would form a double bond here. So we are writing down an ethyl group there. And the other one is it's going to form a double bond here. But which one is major, which one is minor? Look at the double bond. The double bond is here, attached directly to the ethyl group here. So this is a major product, whereas when the double bond up here doesn't have any alkyl group attached to it, it is a minor one. Now let's do example 5.14, question number 1. Now we are going to look at dehydrohalogenation of Rx. Dehydro means we are removing hydrogen. Halogen means we are removing Cl, particularly in this question. So chlorine here can be eliminated by taking one of the hydrogen from the first chlorine and one of the hydrogen from the third chlorine. So for our first answer over here, it is taking with it the hydrogen from the third carbon. HCl is removed. So it will left with one methyl group here on the left and one ethyl group here on the right. So it would be major product because according to size F rule, the most stable alkene is the one that is having more alkyl group. This is R1 and this is R2. Let's look at the second structure whereby the double bond is formed between carbon number 1 and carbon number 2 because chlorine will take away the hydrogen from carbon number 1. So what happens here is that there would be only one alkyl group in this minor product. Question number 2 is 2-bromopropene, where bromine is attached to carbon number 2. So bromine can take hydrogen from the first carbon and from the third carbon, whereby it is going to form a same product, which is a propene. Since if the double bond is on the left, it's going to become the same product as when it will form double bond on the right. Next, let's look at question number 3, where here we have cyclohexane with a substituent chlorine in one of the carbons. So what we're going to form is a simple cyclohexene where the double bond can be formed either here or here. Nevertheless, it's going to be the same product, which is named cyclohexene. Let's do number 4 now. This is a cyclopentane with a bromine and and ethyl. So we are going to remove the bromine together with a hydrogen in the connecting carbon, adjacent carbon. So what we are going to do is form two products. Okay, either it would take the first upper part hydrogen is going to form a double bond over here. The ethyl group is not directly attached to the carbon which has the double bond. And we also going to form a double bond down here because bromine will be removed together with the hydrogen with the lower part of adjacent carbon. So this is the ethyl group attached to the carbon that is having a double bond over here. Therefore, this is the major product and the one up here would be the minor product. Your task is to try and do practice 5.4. Complete the reactions below and label the major product. Draw the structures of A, B, C, D is a reagent, E is another product, and F a reactant, G and H a product, I and J is a reactant, K is a reagent, L and N is a product. Thank you very much for listening and watching. Please focus. Now we are going into more serious matter every day. So I'll see you soon in lesson 64, Electrophilic Addition of Alkene. Assalamualaikum warahmatullahi wabarakatuh. Bye, my students.